So in this question, we want to first start off by deriving the IS curve. So here we should keep in mind what the IS curve essentially is. Now, the IS curve shows all combinations of interest rate and output for which goods market is in equilibrium. The key is that the IS curve represents goods market equilibrium. So when we want to derive the IS curve, we start with goods market equilibrium condition. Given to us as y is equal to z, where we know y represents output, income, or production, and z is demand for goods, which is the sum of consumption, investment, government spending, and net exports. In this case, we know here we have proportional taxes, capital T is equal to small t, while consumption is autonomous consumption C naught plus MPC C1 times YD, which is disposable income. So it's C naught plus C1 Y minus T. Now if I plug in what x's are over here, so this becomes y minus ty. And then if I just factor out a y here, we can write this as c naught plus c1, 1 minus ty. Now investment is given to us as I naught minus br, and g is given to us as g bar. And nx is equal to 0, as what we're looking at is a closed economy. So we start with the goods market equilibrium condition, and now goods market equilibrium is given as, in this case is given as, where y is equal to demand for goods, which is the sum of consumption, which is c naught plus c1 1 minus ty, plus investment, which is I naught minus br, plus government spending, which is g bar. So we've written a goods market equilibrium condition where output, income, or production is equal to demand for goods, which is a sum of C, I, and G. So then we move forward and we can just simplify this a bit when we combine like terms. So we write here C naught plus I naught. So we write all the terms independent of y and r over here, and then we can write our y term here, 1 minus ty, and then our R term here. So in this way, we can just combine some like terms. So this is like the start, how we start. We start with the goods market equilibrium condition. Now, when we plot IS curve, we plot it with interest rate on the vertical axis and with output on the horizontal axis. So now what we're going to do over here is essentially going to be, so since when we plot the IS curve, we have R on one axis and we have output on horizontal axis. So in this equation, we're going to make the interest R the subject over here. So we're going to solve for R in terms of Y. That's the next step. So now we solve for R in terms of Y. As IS curve is graphed on vertical axis and Y on horizontal axis. Right, so here what I'm going to do is I'm going to take the R term over there. So this becomes BR. So this is C naught plus I naught plus G bar. And I'm going to bring the y on the left hand side to the right hand side. So this becomes minus y plus C1, 1 minus dy. I'm going to divide both sides by b. C naught plus I naught plus G bar divided by b. And then what we're going to do is we're going to factor a minus from here as well. Minus 1 by b. And then 1 minus C1, 1 minus Ty, right? So here what we've done is we factored minus and the y from here, and then we've divided both sides by b. So this is the equation of our IS curve such that we're plotting R on the y-axis and we're plotting y on the horizontal axis. So this is for this. So now we can move on to the next part now. So just keep this in mind when you're deriving the I-square, you start with the Guth-Michael equilibrium condition, then you can just solve for R in terms of Y. So now let's look at the next part. So the next part is asking us to use the expressions to find the slope and the vertical intercept of the I-square. Okay, so let's go to the next part. Now part two. To do part two, you should recall something. Now, in this case, the I-square we're looking at is linear, right? It's in the form of a straight line. So for this, we want to recall general equation of a straight line. So the general equation of a straight line is y is equal to mx plus c. Now, mx here represents the slope. Sorry, m represents the slope here, and c represents the vertical intercept. Right, so this represents the vertical intercept, and this represents the slope. Now, in our case, our I-square, which is in the form of which is linear in this case. So its equation we know is R is equal to, we just found this in part A, 1 minus C1, 1 minus T, and then it's divided by B, and it's Y, and it's plus C naught plus I naught plus plus G bar plus G bar divided by B. So now if I compare the equation of the I-square with the equation of a straight line, so here we can see R represents the variable on the y-axis, on the vertical axis. Y represents, in this case, the variable on the horizontal axis, the x-axis. So we should not confuse this y with this y. This y is our output, income, or production, which we're plotting on the x-axis instead of x over here. This y is just when you're plotting an equation, the variable on the y-axis, right? So the idea is that if I compare the equation of my I-square with the equation of the straight line, R is the variable I'm going to plot on the y-axis or vertical axis. Y, output, income, or production, is the variable we're going to plot on the x-axis or the horizontal axis. So if I compare them, I can see the coefficient of my variable that I'm plotting on the x-axis represents the slope. So this is the slope if we compare this. And you can see that this is the vertical intercept of our IS curve. Right, so this is the vertical intercept of our IS curve. So slope is minus 1 minus C1, 1 minus T, and then we divide it by B. And vertical intercept is just simply C naught plus I naught plus G bar divided by B. So if I were to just roughly plot my IS curve over here, okay, let's just make this better. So if you were to roughly plot our IS curve over here, on the vertical axis, like we said, we're plotting R. On the horizontal axis, we're plotting output, income, or production value. So if I plot it like this, so the slope in this case will just be, so we'll look into this, the slope is negative. We'll discuss that in the next part, but it is negative, so we're going to plot it like this. So we'll discuss this further in detail in the next part, but this is just to show you sketch. And the vertical intercept is this, and this will plot as C naught plus I naught plus G bar divided by B. So it's this Y value over here. Right, so this is how we can, or we can just write it differently. We can write it here. So we can write it like this instead. C naught plus I naught plus G bar divided by B. So once you compare, because the IS curve in this case was linear, so we could just compare its equation with the equation of a straight line and see the coefficient on the variable that we're plotting on the x-axis is the slope, and the constant term that we have is the vertical intercept.